So again, just to remind those who on the YouTube who's starting, because we have the videos separate, this webinar was all about the emergence of small-scale LNG globally. And we have our panel here at top right on my screen is Freek van Heerden from OTC, Kathy Farina from Peleotech, and Yuri Steyn from OTC. Right, so I'm going to go through the questions from the bottom to the top. And there's a very good starting question from H Square Engineers, who I think I'm going to address to all three of you, please, just to get your perspectives. So the question from H Square Engineers is, who are the ideal stakeholders and customers that should be considering small-scale LNG solutions? Let's start with Kathy, if you don't mind.
Sure. I think there's a couple different types of stakeholders, I think, that are that should be actually looking at small scale LNG solutions. I would say those upstream and midstream operators, companies with that stranded flare or low volume gas. So there's some stranded gas or flare gas. We've been seeing a lot of interest in flare gas right now. Looking at seeking that gas monetization, so it's getting some profit from that gas. So those are one of the stakeholders. We're also looking at, there's different ones, like say in the mining sectors, definitely looking at mining operations, replacing that diesel, looking at some of those kind of stakeholders as well. So some of those mining users as well. And then I think looking at virtual pipelines, so any of the LNG distributors, any of those developers, that type of thing, for putting in that trucking, so LNG trucking and distributed LNG chains. Yeah, those are kind of some of the ones that come off the top of my head. I'm sure Freek and Yuri will add some more.
Okay, well, thanks, Kathy. I think you come with the Canadian perspective, which is very helpful. I know that both Freek and Yuri have been doing work more locally here in Southern Africa. And maybe let me move on to Freek and ask you just to expand on what Kathy has mentioned and what what ideal customers for small-scale LNG do you see in this part of the world?
Thanks, Gavin. Yeah, I think Kathy had a good explanation. For us specifically, what we've seen is there's a number of people that have sort of licenses or exploration licenses on local sort of gas fields, especially the sort of inland gas fields. The issue I see in South Africa, why these fields are not being developed is, and as Yuri mentioned, in order to put in a big pipeline, you actually have to have a big offtake on the other side to justify the pipeline. And in the past, that was sort of the way gas fields have been developed. I mean, if we take the Mozambique development, Pande Temane, Sasol had to guarantee a gas offtake on this side so that we could justify the pipeline. And I think that's one of the reasons why the development of these other CBM type resources are slow. And I think for those owners of those fields, the big issue is to prove the gas field and prove that some of the wells are actually producing what they say. And for that, I think a very small scale, like a 5,000-ton plant, is ideal. Once you've proven the plant, you can go to 60,000 modules, for example, and eventually build up enough momentum to connect a pipeline into the network. So those sort of people are very interested. The issue, of course, is that the gas field owners are not so interested in liquefying the LNG. They want to sell gas at the top of the well. So here comes in any sort of distributor or energy trader, marketing guy that could put up the LNG plant and then market it. Or on the other hand, as Kathy said, people that are in need of the LNG, and there's a big need in this area, could sort of by themselves go and make a plan with a gas owner and actually put up the plant and buy the gas off the wellhead. I think that's me stop there and Yuri can talk a bit.
Yeah, thanks to Freek and Kathy for two excellent answers. Makes it more difficult for me, of course, but what was not mentioned is the fact that there's also coalbed methane in Limpopo province and in Botswana, which is a significant source. And of course, the issue of biogas. Biogas facilities would typically require a very small-scale LNG facility. As Freek said, you can start with a small unit and go to maybe a larger unit if there's more gas available. But you can also start with a small unit and put in a second or a third or a fourth small unit. You remember that one photograph I showed with 30 of the small Galileo 5,000 tons per annum units. So there are many ways to kill a cat. There are many relatively small sources of gas available in the country. And yes, depending on the situation, you pick the best option. But I think there are many opportunities in South Africa for small-scale facilities.
Excellent. So it seems to me that it's one of the big reasons for implementing small-scale LNG is to monetize something that you already have. Now, Kathy mentioned monetizing flare gas. The other is to take stranded gas resources and turn that into something useful, and that's where we see the gas fields. So, you know, you've got the pull, but what's also very nice about small scale is that it makes it possible and economical to take something like biogas and turn that into something useful. And so it seems to be quite a wide range of different applications and customers that are in this market. And that's great because, again, it comes back to my ecosystem analogy. Lots of different species of fish that have to feed off of each other. And not all of them can make the large-scale investments necessary to bring in the heavy industrial use, but more the smaller-scale stuff, where conversion into fuels, for example, replacement of diesel, that can become feasible. But that's great. So let's move on to the next question. I was quite intrigued. Somebody mentioned, and I can't remember who, virtual pipeline. And this ties into the next question, which is, what is the typical mass of LNG distributed in a road tanker? And that question came from Petrus Skoltz. So I wanted somebody to answer, please. Maybe I'll direct this to Yuri, you initially. What mass of LNG is distributed in a road tanker, and what actually is a virtual pipeline?
A virtual pipeline is what happens if you start producing LNG and distributing your product via tanker or train or ship to other areas. It's not a pipe, but it's a means of conveying your product to the end user. As to what mass of LNG is typically distributed in a road tanker, I'm very fortunate. Mr. Tim Larner of FFS answered that question for us, and he says under the South African Road Ordinance, a payload of up to 25 tons is now possible in South Africa. Isotainers are built specifically for the purpose of transporting LNG, and they come in a range of sizes, and the maximum size you can use in South Africa is now this 25-ton units. So a virtual pipeline, again, it's not a physical pipeline, it's another means of conveying your product. And remember I said that we only liquefy gas to be able to reduce its volume to make it more convenient for storage and for transport.
So Yuri, I've got a follow-up question now. I'm just thinking, LNG, is cold. Surely the gas boils off when it's in storage, and also when it's in your road tankers on the road. How do you handle the boil-off gas that comes from LNG in storage? This is still to you, Yuri.
Okay. Yes, the gas does boil off, but it's a function of how well the container is designed, the tank that you store it in, how well it's designed and how well it's insulated. If your tank is close to the liquefaction facility, it's obviously not a problem. You can recirculate the boil-off gas, take it through the plant again and reliquefy it. So that's not a concern. In things like the marine transport of gas, where ships take several weeks to reach their destination, there's also a great option where you can take boil-off gas and use it as an energy component to enable the transport of the ship, to run the ship's engines from it. So that is a great solution. When it comes to transport of isotainers, it's regarded as, well, it takes too short a period of time to really generate significant boil-off. One of our engineers in OTC has seen imported isotainers with LNG stand for several months before there was any pressure buildup in the unit. So boil-off is, it happens, but it's relatively low. And as Freek also indicated, if you store it under a slight pressure, obviously you must monitor that pressure and release gas if the pressure builds up too significantly, but it doesn't happen. It takes a long time. So boil-off is a factor of life, but it's not a real concern. It can be treated.
Okay. Thank you, Yuri. And just a reminder, please, if you have any questions, please put them in the Q&A box. I mean, one of the benefits of attending the live webinar is that you get to interact and ask your questions directly. I'm going to address the next one to Freek, and it's again from Petra Skulds. Do we have a typical range of complete plant capex costs based on, let's say, a 50,000 tons per annum plant? Freek, have you got any comments about the capital investment levels needed?
Yeah, I can talk a little bit about it. If you look at a totally integrated plant, the cost really is quite affected by the quality of the gas coming in. I'm not just talking about liquefaction, but the whole process. So there's typically in my mind, a cutoff here at 1 or 2% CO2, which is one of the main components. If the CO2 goes above that, you have to employ either a membrane system to remove the CO2 or an amine tower type of scrubbing system. If the OTC is below that amount, if the CO2 is below that amount, you can typically just use a MOLSIF unit to mop up the last bit of CO2. Of course, the water must be removed. The gases often are saturated with water at the beginning, and you have to get it to the 0.1 ppm, and then you have put in the liquefaction thing. So let's sort of consider the sort of worst case scenario. Let us say you have sort of 6 or 7% CO2 and maybe the same amount of nitrogen. That gives you sort of in the high 80s of methane. For that system, I think the typical capital cost for the plant installed and ready to operate, not ex-factory, is, I think, around about $70 to $80 million. Of course, as I say, if you connect this plant rather to a pipeline that is fairly clean and you just have some mop-up stuff, the cost is probably slightly more than half of that, say $40 million or $50 million of that order for a 60,000-ton plant. For a 5,000-ton plant, we're talking somewhere between $5 and $7.5 million roughly. The liquefaction is less than half of that, the liquefaction module. Probably, I think, I don't know, 30 or 40% of the cost is actually the compressor. The compressors are quite expensive, going up to 40 and 50 bar and things like that. So that's typically, I think, for the 5,000 ton is typically $2 million or $2.5 million just for the compressor. So very important to get a affordable compressor, but a compressor that's not inefficient either. Now, if that is enough explanation, Gav.
I think that's great. I think it's therefore what you're saying is it's important to get the battery limit conditions very clearly defined. You know, what is the pressure and the quality of the gas coming in, because that will have a big impact on the capital cost. But capital cost is not the only factor, and I want to move on a little bit more quickly if we can. The next one is going to go to Kathy, because it's also about operating costs. And H Square engineers have asked a follow-up question. What is Pileatek's SSLNG solution advantage in terms of methane conversion efficiency and feed gas flexibility, including CO2, nitrogen, and hydrogen sulfide tolerance? Kathy, have you got any comments on that?
Yeah. So our methane conversion efficiency, we can get 92%, say, methane conversion when we've got 98% methane coming in. But that's comparatively where we feel that is the highest so far that we've seen within our competitors. A lot of our competitors are, 75%. Some of them are lower. Again, it depends on that feed gas coming in. So it depends on the nitrogen content that you have coming in that you're going to get your methane conversion. But based on a 2% nitrogen and 98% methane, we can actually get a 92% yield, methane yield. And as far as the flexibility, we do have a battery limit that we have a maximum that we can take for our LNG units. And when we're talking about nitrogen, we can take a maximum of 6%. And with CO2, we're around 40 ppm. And the H2S, we are going to be around 4.8 milligrams per cubic meter. So there is, we do have a specific battery limit on what our maximum allowable is, and that's going to really determine then your upfront feed gas cleaning that is required. So hopefully that answered it, but 92% yield, methane yield, and then a certain maximum for those other components around the feed gas.
Okay, very good. And that will convert obviously to operating efficiency and operating costs. And then
Absolutely.
Obviously you have to look at the total cost of ownership of this thing. So it's both capital and operating costs in order to evaluate your solution.
Yeah, and when we're looking at what Pileatek provides, we're providing the export modules for the LNG units. And then when we're looking at the total solution, that's where we're going to have to look at is the total solution. What's the upfront, upstream, and downstream also components to the plant.
Yeah, and also the fact that it's modular and reusable to some extent is also another factor. Great. So I've got a few more questions, and I'm going to have to stop on time. So Andre Hugo has asked, and let me just see. Yeah, I think Yuri, or would you be able to take this one? But the question is, what is the production cost range for the P5 and P60 in dollars per gigajoule? What are the cost components weighting? For example, capital, power, and OPEX. How much power is required to liquefy a normal cubic meter of feed gas? It's probably quite a detailed question, Yuri. I don't know if you want to have some comments, but maybe you want to point Andre to the right resources if you can't answer them offhand.
Well, I think this is more a question for Kathy. because it deals specifically with the P5 and P60 offerings from Beletec. We've done some work on it, but I think let Kathy start, and then Freek can come in as well.
Yeah.
Kathy.
Yeah, so this is also looking at, so again, with the Beletec for the P5 and P60 for the X-Works, with our liquefaction modules, we have a specific CapEx for those, as well as a specific OpEx. But when we're looking at the total solution, that's what we're looking at for the dollars per gigajoule. So, you know, we could give you just the specific dollars per gigajoule for the PTI or for the Beletec. But when you're looking at that, you really want to look at the total solution, because if you're looking at dollars per gigajoule, you want to look at what is your upstream, what is your downstream. So maybe Frick can actually add to that component of it when you're looking at the total solution for a small scale LNG. And the power, around the power side for our P5, if we have pipeline gas that's at a 30 bar that we only need to compress a little bit, like the small amount, you know, around 280 kilowatts is around the power for the P5. And that's, again, with the pipeline, kind of a higher bar. If we're looking at kind of a more atmospheric, like maybe a biogas or potentially a flare gas, you would have a higher power because you would have more of a compression up at the upfront, upstream components. And then same with the 60. So if you have actually pipeline gas that is actually at a 30 bar, around that, we're about 3.5 megawatts. So that's kind of the power between the P60 and the P5 for our specific solution, which is actually quite a bit less than a lot of the other solutions out there. I'll maybe pass it to Frick to talk a little bit about the dollars per gigajoule.
It's a bit of quite a detailed sort of question. On OTC side, we've done some basic economic studies, assuming that you want, say, a 12% return on your IRR return on your plant, and the liquefaction cost, the total value chain liquefaction cost for a 5,000 ton plant, which of course doesn't have that much economics of scale, Andre, I thought would come to around about $6 to $7 a gigajoule, all inclusive, for a typical plant. And for a 60,000 ton plant, the calculation came to around about $4 or $5 per gigajoule. So if we say, for example, you get gas in, you buy gas in at, say, $5, and you have a 60 kiloton plant, maybe you need to add another $5. That gives you conceptually about $10 at the factory gate, and let's say $2 to deliver, which gives you around about $12. That's sort of conceptually what's in my mind, but 12% IRR may be a little bit low. Maybe people would want more. But in that calculation, we were comparing imported LNG landing in Gauteng versus trying to manufacture it ourselves. And there's a specific one of the inside articles of OTC and looking at that sort of scenario, comparing it of bringing small-scale LNG from Botswana. That's the one we specifically looked at, where we said $12, $13 landed in Gauteng may be possible. But I think we can talk more detail with Andre if required.
Okay, thank you, Freek. I'm under strict instructions to meet the time limit. So we've got 2 more questions, but we're going to take those questions and answer them on the YouTube video. So Wilhelmine, I'm going to pass it back to you in a minute. But thank you, everybody, for your questions and your participation. Thank you for the panel and your insightful answers. And I'm pretty sure that each one of you will be available for any other follow-up discussions after the session. So our next question is from D. van der Merwe. Frick highlights environmental performance. Could you briefly comment on the comparative environmental leakage risk of various LNG, CNG alternatives? Frick, can you answer that?
Yeah, I don't think there is much of a difference whether it's LNG or CNG. As the gas, it's all methane. Methane has quite a high environmental greenhouse gas impact. It is becoming more and more important that one actually do not let methane leak into the environment and so on. I'm not sure whether there's a big difference whether it's CNG or LNG. CNG, of course, is at a much higher pressure, generally 200 to 300 bar. So if there is a leak, it leaks a bit faster. But in general, you have to keep the LNG or the CNG methane inside the vessels, and I think one has to design the equipment really such to minimize leaks. And also what has been in my mind was when we started working with vinyl chloride monomer, Gavin, in our young days, which was sort of set as a carcinogenic, we had to install sampling systems all around the plant to really detect leaks very quickly and so on. And one maybe have to do some things like this in general, just to make sure maintenance is done properly and that you detect leaks in some proactive way that you can very quickly fix. But for all the cases, it's the same, I think, basically on the methane side. You have to make sure you lose as little as possible. And that comes to the well-to-wheel story, that total methane loss across the whole chain. And I know that Yuri has been talking a bit about that. The people are comparing methane well-to-wheel versus, say, diesel well-to-wheel. I don't know if there's any comments on that.
Well, I think, Gavin, the important thing is that if you have a leak or an emission of methane, you want to prevent the impact on the environment as much as possible. And we've seen through some very basic calculations that if you convert your methane, or if you burn your methane, you end up with CO2, and the volume of CO2 generated has a significantly lower impact than the original methane would have had. So if there are leakages which you can contain and send to a flare, please do so. That's the best option if you have gas leakages from out of your system. Spurious leaks are a different thing, and as Freek indicated, that you can capture with the appropriate sensors and take appropriate action when you find that there are leaks in the system.
Yeah. No, thank you. I think that answers it very well. I think the whole value of LNG partly is its environmental, it's less damaging to the environment. So what you don't want to do is offset that by having a whole lot of leaks out of your equipment and your plant and so forth. Okay, I think we've got two more questions, and the last one is going to go to Kathy, just a warning, and that one is about when do you expect the first Beletec to take off. But before we get to that one, Bruce Bassett asks, if biogas is considered as a feedstock, what is the expected capex percentage for cleanup of the CO2, hydrogen sulfide and water in the gas? So I'm not sure who's going to take this one. I know you've done quite a bit of work on biogas. Maybe you can start with the answer.
I can start with the answer. I won't be able to answer the full question, but biogas is probably the worst gas to start off with, primarily because its methane content is the lowest of all the different sources. Typically in biogas, you start off with a gas of 55% methane and 40+% of CO2 plus other contaminants. So the percentage that has to be removed is significantly larger, which means that your pre-treatment facilities will be larger and more expensive.
So are we talking about half the capital cost, or is it 3/4, or is it much less? I'm trying to get a sense for it.
I'm going to let Freek answer that part.
Okay, Freek, would you like to comment?
Yeah, no problem. As Yuri said, it's by far the worst gas to consider is at atmospheric pressure with 50% methane. So when I mentioned the sort of, let's say, conceptually $7.5 million for a total 5,000 ton plant from cleanup from atmospheric pressure, that assumption was 85% methane, roughly 85 to 90%. Now we have to drop that to 50% methane. Going from, say, about 50-50 split between liquefaction and cleanup, we're now going to go to probably say maybe 60% or even more of the cost going into cleanup of the gas. There's quite a number of complications with biogas. There's quite a bit of sulfur in it. There's siloxanes in it that has to be removed and all sorts of other things. So you probably, I don't know, say roughly 65-70% of the capital now ends up in the cleanup side, I think, maybe even a bit more.
Yeah.
So I mean, that again underlines what we said earlier, that it's so important to have a clear understanding of the battery limit conditions when you're comparing the different technologies, because if such a big portion of the capital is in cleanup.
Yeah, and compression of the gas.
Yeah, it can be misleading if you just look at the capital cost of the actual LNG units, when most of the money is going to be spent just cleaning up the gas. But let's let the last question, Kathy, this one's for you from Petrus Goltz. And when do you expect the first Pelletech project to take off?
Well, we're currently working on a proof of concept, but it would be a P5, so it would be our first kind of commercialization. And that is in the works. We're working on getting some funding. So the one thing is if you are interested in Pelletech, we'd love to hear from you. But yeah, once we get some funding, we're going to be full out and develop hopefully within the next year our proof of concept planned.
That's great news. I think we all look forward to seeing that succeed, and all the best. So I think that ends my list of questions. Wilhelmine, back to you.
Thank you, everybody, for staying with us to the real end. Gavin, well done with that facilitation job. Really appreciate that. Thanks again to all our speakers for the effort you've put in preparing, for sticking to the time limits. It's absolutely amazing. Everyone stuck to their time limits. Thank you for attending. Really looking forward to see each and every one of you next month. With that, I'm going to end the webinar.